I hope. Okay, now we record already. Right, so looking on this, okay, we focus on the first chapter, which focus on the energy for human use. So we start with this one, and later we proceed on the chapter 2 and up to the rest. So in this subject, we focus more to two kind of energy, whereby known as the non-renewable and renewable energy. So in our first chapter, we will focus on the use of energy in the society, energy transformation, yeah. So how can we get the energy, yeah, by transform the, transform the energy from one energy to another energy. And then we look at on the key environment concern, the impact, and then the potential, and etc. Okay, now we look at on our note. I have a two note over here, so maybe we start from, okay, hold on, I show you the first note. We start with, could be we can start with this one, okay, right? Okay, can you see my slide, Ayu? Right.
Yes,
Can you see my slide?
Yes,
Yes,
Prof.
Prof.
All right, so talking about energy, right, talking about the energy. So let's start with, maybe we need to look at some, like this, yeah? The first locomotive system, okay? The first locomotive, we have a look how it's working, yeah? Right. Right, we look at on this video, yeah? You see, okay, have a look. You see the first locomotive system in the world. Now, as you can see, all right, this is the driver. You can see this is the body part of the engine. So you can see a lot of a huge gear around here, yeah. And then the, the wheels is on here, the wheel, and then we have very big wheel, and then we have the what do you call it, chimney here, the chimney, yeah, the chimney, whereby the chimney is like the exhaust. So in this context, so we need to consider, okay, what we need to consider is how this system works. So this is the first locomotive in the world, the first generation, yeah. Well, so what we need is we need to apply the input energy. We need to apply the input. So there must be input energy in this system. So this system considered as isolated system. Isolated system means there is no energy loss. So mean we apply, or you need to input the energy. So what kind of input energy? We use so long time ago, the people use a charcoal. You know charcoal, yeah? A coal, yeah? A charcoal. Then we burn the charcoal inside this vessel. From there, from the burning, so we produce what? The heat energy. And the heat will be what? Boiling up the water inside there. There must be a water inside here. So come up with the vapor. And then we have the vapor and come out from the, or the smoke, we come up from this exhaust. So this is, have the input into the system, and then we have output. Output, yeah? Output. Okay, have a look. So what we have around here, we have the mechanical system. All these are mechanical system, yeah? Mechanical system. Right, we need to consider as well, because they use a charcoal, and they have got a smoke around there. So this smoke, sometimes there will be emitted the CO2. CO2, okay, CO2. And of course, CO2 will be considered as a polluted gases. So mean that in this context, if we have more vehicle around the world, you can predict so what the polluted will be then. Yeah, it's like in Malaysia. Before we are in MCO, there is no car in the highway, no car, yeah, in the highway, and then the environment is clean. It's like in China long time ago when they got COVID-19, yeah. So all the people are MCO. So no car. Then no car, then there is no such pollution occur in the environment. So what I'm trying to say is, in order to get energy, sometimes we have to consider a risk, the risk in terms of the emission from the polluted gases, okay, that come from the engine. Now, see, it's very slow engine, yeah. Right. Now it's okay. Now at least you get some point. You get some point by looking on this system, yeah. All right. So from here we can see that in terms of the energy revolution, we're talking about the energy revolution. Yeah, maybe in the prehistoric event, long time ago, yeah, the people maybe use wood as the source or biomass. Yeah, long time ago, the primitive people used the wood. So sometimes we can consider as a biomass, maybe biomass. Yeah, right. They burn the biomass and give the heat. The heat from the heat will give us energy. And sometimes maybe they use animal. Yeah, or maybe the water, yeah, the wind power and so on. But in terms of the energy, could be, it's not powerful compared to nowadays one. Yeah, right. In terms of revolution, what we can see is that there is a evolution of the energy. Yeah, okay, you can see from the history, from the prehistory, and then the industrial revolution during the 18th century's era. So the people, okay, more focus on or move to the use of fossil fossil or a coal that I show you just now, the steam engine. We have the steam engine. Yeah, right. Then afterward, and in terms of the measurement, okay, for the energy, normally they use one, or we calculate, or we estimate by using a term of 1 horsepower. Why horsepower? Because maybe a long time ago, the people measure the energy based on the power of the horse. Because as we know, the people, there is before this, there is no transportation. The people use a horse, especially look at on the cowboy film. Yeah, if they want to go one location to location, they use animal, a horse. So that's why they put 1 horsepower, whereby 1 horsepower equivalent to 746 watt, or equivalent to 746 joule per second. Right, but in the era of industrial revolution, they use BTU. BTU stands for British Thermal Unit. British Thermal Unit, yeah, 1 BTU. So this equivalent to 1055 joule. Right, later, yeah, during the industrial revolution, 1818s, now the use of fossil and fuel is become very dominant. Yeah. Now revolution, you see the revolution. Even now, we have the term of industrial revolution 4.0 and so etc. Okay. Now if you go back to the 18th centuries or 19th century, long time ago, there's beginning of the industrial revolution. So the people use this fossil and so on. Even sometimes you watch the movie, like Lord of the Ring, for example, you can see in the movie, reflect to that era, whereby they use the wood, they chop down the wood and then they use the wood. If you watch the movie, Lord of the Ring, this is reflect to the what they call as industrial revolution, because in the world, the first industrial revolution is occurred around European and especially in England. That's why nowadays, if you go to England, there is no tree. No more tree, except you can see sometimes if you go down to the south of the England, you can see only 1 tree on the top of the mountain. Even if you go to Scotland, no tree, no more tree. Yeah. But in our country in Southeast Asia, in Malaysia, we still have a tree. Yeah, Alhamdulillah, we have a tree. But you go to England, there is no tree. Yeah, I can show you some picture later on. Okay. Right. Now the fossil. We have the fossil, and then from here, from the fossil, they use gasoline and turbine, and then we have the electricity, and then we have internal combustion. Now, from this is we call as the input one. Yeah. Right. In terms of the use of the energy, you can see the evolution around the world. Yeah. All right. You can see this is a tip from this reference. So during 1 AD, maybe the human population around the world, maybe somewhere around there, some around the Ganges area the Ganges River, maybe around the river somewhere around China, okay, and then maybe in Malaysia. That's why you go back to era of Kesultanan Melayu Melaka. Okay, that's why Malacca had become a big empire a long time ago, because Malacca is very close to the estuary of the river, nearby the river. So during that time, the people the human population focus their life in the area nearby the river. Why? Because from the river, they can get the resources or the water, even maybe they can use the river to become energy and etc. Right. Now you can see, and then even maybe in terms of population, so many. But then you can see afterwards, after 130, and then you can see the human population is become, increase and increase. Even some people from UK, they move or they emigrate to American. Right. Now, in this context, maybe I need to share with you some history event. The first person who immigrate to America is they call as John Cabot. John Cabot, yeah. His first navigation, his first navigated to America is somewhere around Bristol, at my place, at my alma mater, my alma mater, Bristol. So that's why if you go to Bristol, there is a statue of John Cabot. John Cabot is the first British people who discover America continental. Yeah, even Christopher Columbus. Yeah, but the first person who discovered American is John Cabot from UK. Now, and then we see from there, immigration from here, immigration from there, and here, you see in the India area, and here. So if there is more people, then the use of energy is very important. More settlement, then more energy. And most of the area are located somewhere around the shore or nearby the beach area or nearby the river. So in terms of activity, they focus on agriculture. And because of settlement, maybe there must be a deforestation. They cut down the tree, for their home, for their settlement, etc. Okay, right. That's why if you look on peninsula of Malaysia, there are a tree. The forest is only at the middle of the peninsula of Malaysia. Yeah, right. Because the people the population are focused on nearby the shore or nearby the beach or nearby the river and so on, etc. It's like Kuala Lumpur, the name of Kuala Lumpur, because nearby to one river there in Kuala Lumpur. What river is it? Yeah, Klang River. Yeah. Okay. Right. Then we have the pre-industrial age population. You see, 1700, so many people here, so many people in India, and over here even Southeast Asia as well. And then the forest is depleted. The forest is depleted in Europe. Why? Because the thing is they cut down the tree. Yeah, for energy. They cut down the tree for energy. Okay, and then wind power also used to, and even so many things, for many activity. And at T00, the people changed too. During this time, please turn off your microphone, please. Okay, then 1800, discovery of what they call as steam engine. During steam engine, they use a charcoal. So they use a charcoal. What is charcoal? Charcoal is from actually originated from the fossil. Okay, from the fossil. So fossil contain carbon. From the fossil, it contains carbon. So fossil is the organic form that lived long time ago, and they remain in the rocks. And from time to time, after several thousand years, this fossil, this microorganism form will change to or decay to become a carbon. So they call as fossil. Yeah. So fossil contain a carbon. From carbon, we have the coal. Then afterward, in terms of industrial revolution, in terms of the technology, it's changed from steam engine to could be electrical engine. Now, when turned to electrical engine, okay, some part they use a biomass, like a charcoal. Now, even in Malaysia, for example, right now, the energy that we have we have the electricity at home. So you need to think where the energy come from. It's from, maybe some of you saying that, maybe from the hydroelectric dam, yeah. But you have to notice some of the system that TNB supply for us is using a charcoal. They buy a charcoal. See, Malaysia could be don't have any charcoal, they have to buy from other country like Indonesia, maybe like China, and then we have to buy the charcoal, and from the charcoal you use it to generate the power, yeah, from our generation system, generator system. They use a charcoal, and also maybe they use the oil and gas. Okay, oil and gas. All right, now in terms of energy in Malaysia, okay, TNB actually use two kind of system. Maybe they use a charcoal, sometimes they use a dam. Okay, but for the dam, for the hydropower, we have to notice, not even the whole entire year there is a water. Sometimes we have a drop, no water. If no water, then the water level is not powerful to push the hydropower system. Then there must be a backup. They use a charcoal. Is it clear? Yeah, I heard all of you are clear. Then you can see from time to time, in the World War II, then they use using a gasoline, a diesel, and then even the nuclear power introduced during the era 1950. And we have to notice that during this era, the first atomic bomb, during World War II, there are American scientists already created the atomic bomb. So it's not only for the peace, but the thing is they use the nuclear power for energy. That's why sometimes if we talk about nuclear, some people have a phobia. In this case, we know nuclear power is green technology. Yes, we agree, a green technology. But in some case, there will be incident, a catastrophic disaster. Like in the case of Chernobyl, for example, in Russia. And then like incident in Fukushima and Nagasaki, in 3 Mile Island in America. So even though nuclear power are very clean, but in terms of the risk is quite high. Yeah. But until now in Malaysia, there is no nuclear power yet in Malaysia. So in Malaysia, we are depend on the charcoal and also hydropower. Yeah. Okay. Right. Now, in some of the country, like European country, for example, they use nuclear power to generate electricity. Now, I still remember when I did my PhD in UK long time ago. I've moved about 3 flats. The first flat I ran in the university. We use from the gas. And then even the electricity as well. Electricity by the power gen, but in terms of the heater, because we are very lucky because we live somewhere around the equator line. We have hot weather all all over the years. But if you live somewhere around this area, European country, there are 4 seasons. You got winter, then the temperature will drop up to negative, maybe drop to below than 5 degrees Celsius, especially during the winter time. Winter time, they are very cold, very cold. The temperature surround is about sometimes negative 5, we are very lucky then. In most of the country in this area, okay, the North Saltish or the South Saltish, they have for weather. So because of our weather, during the winter time, the people need what? To heat the heater. In order to generate the heater, of course, they need energy. That's why in UK, in terms of power, they have a many kind of power system. And even sometimes in UK, they buy the power from France. In UK, they have like a company like we call as British Gas. How they generate the power? Either using the charcoal, but using the nuclear as well. But sometimes they have to buy. I should remember when I moved to my second flat, somewhere around the middle of the city, we have to pay with a lot of money then for the electricity. Because why? Because when I speak to the officer of the EDF, if you watch the football, the English Premier League, you can see sometimes in the panel there, they got EDF Energy. That EDF is the company from France, whereby in France, they generate the power by using nuclear power. So they generate the electricity using the nuclear power, and then they distribute the electricity to UK, using the cable. All right. So now, in the case of in our country, in Malaysia, we are very lucky because we only have one company. But if you go to another country like UK, like European, there are many more energy provider. In Malaysia, we depend on TNB. If you go abroad, in America, or maybe in UK, there are many provider. It's like if you subscribe the mobile phone, you can either use Celcom, you can use Maxis, you can choose anyone you want. Okay, but in terms of energy use in the country like UK or maybe in Europe, the people can choose which one they want to go. Okay, but EDF is quite expensive because they use nuclear power. Okay, I should remember there is a dialogue long time ago. I represent UTHM, attend the nuclear dialogue in somewhere around KL. And then I speak to one of the representative from US. I asked him whether there is a reduction of the electricity bill in the future if Malaysia goes with the nuclear power. The answer is no. I expect that it should be reduced, but then the answer is no. Because in this context, nuclear is just in terms of backup power. It doesn't mean that if Malaysia have a nuclear power, you don't ever expect that your electricity bill will be reduced. It's not like that. It's only a backup power. Why? Because we have to notice, in our country, Malaysia, even in Indonesia, the use of electricity is not only us as a resident, but in industry. We have so many industry. Like in Malaysia, for example, you go to Kelang Valley, go to Putrajaya, you go to Port Kelang area, there are many industry. Even you go to Petaling Jaya, there are many industry. Even you go to Melaka, Aikro, there are many industry. If there is many industry, mean that a demand of energy very high. Okay, right? Then until now, you can see the evolution. Maybe in the future, we are somewhere around 2021 now. Now, if you look at on this distribution, now you see in terms of the population, the people, black color here mean that the human population is increased. Then in terms of density, the density of human population become very high. So when more people, then more people need power. Even now, when pandemic, everybody, if there is no electricity, then you cannot access to the internet. You cannot turn on your modem. You cannot turn on your mobile phone, and etc. Until now, then even in the future, we don't know what happened then. That's why this we call, okay, all these are as we call as the use of non-renewable. Non-renewable mean we are depend on the non-renewable energy like what? Like the fuel, like from the petroleum, like a fuel like charcoal. And even when you say about the nuclear power, also that nuclear power is originated by a uranium metal. Uranium is the fuel. Whereby you get the uranium is from the core of the earth. And uranium is the fundamental element to generate the power in nuclear. Uranium is a mineral. Yeah. So in the world, yeah, the country that have a vast amount of uranium is Australia, Africa, yeah. But in Malaysia, no. But I heard that maybe somewhere around one area in Malaysia, I noticed that there is a one area that covered with some amount of uranium, but not so many. But talking about this uranium, the uranium will be abundant all over the world. Yeah. Okay. But we're not sure in Malaysia, maybe in future, the use of nuclear power, I'm not really sure. I cannot comment on this. But the thing is in the future, if there is, we need to notice another 20 years time, we are depend on the what? On the fuel somewhere around the southeast area here. We have the Petronas Carigali. Yeah. Petronas Carigali drilling the oil here. But we don't, how long the petroleum can be extracted from that well somewhere around here. Okay, we cannot comment on this. And what we can say, another 10 years time, another 30 years time from now, maybe the source of the oil will be depleted and gone. That's why now you could be here of familiar with the term of renewable energy. Why the people are thinking about renewable energy? Because we expect that another 20 years time from now, 30 years time from now, we're not sure whether there will be a fuel or not. There will be oil and gas or not in the future. Yeah. But like a country like Brunei, Brunei, they are very rich because they're a very small country, small population. Even they have so many fuel well. Yeah. Okay. All right. Okay. Now we finish on this. This is what we need to consider. What is it that happen in the term of energy in especially in the area of Malaysia, Indonesia, and etc. Yeah. Okay. Right. Now, why fossil? Why fossil? Why is so special with the fossil? Because, yeah, the answer is the fossil contain with a carbon. In terms of energy, you can look at over here. The gasoline give you around this amount of energy, which is about 115K BTU, or equivalent to 120 megajoule. Okay. While for the coal, give you 15 only. Yeah, which is lower. Which one is better? Coal or gasoline? Gasoline is much better because it can produce more energy. Okay, if we compare to the biomass like a wood, see, it's very small, 7.5. That's why you can see in the previous picture just now, yeah, the first technology are based on the biomass or maybe based on the charcoal and wood. But one after the people discover gasoline, then they change everything. The technology will change, the engine will change, everything is changed. Yeah. Okay, fossil can be easy to be transport. Fossil is very easy to be transport. Even the charcoal, yeah, There are so many charcoal all over the world. So many charcoal, yeah, so many charcoal all over the world. But in Malaysia, we buy the charcoal, yeah, from outside. Okay, even to take the charcoal is quite risky. There is incident in Brazil or Peru. I still remember the charcoal worker have been buried underneath several kilometers down the ground. Yeah, one after they got collapsed. Yeah, the cave if collapsed, then it's quite risky. Then, yeah, you remember in Peru or in somewhere around South America. Yeah, right. So how fossil works? Fossil contain with a carbon, as I said. Yeah. So we have like a compound like CH4 or methane. This is the simplest organic hydrocarbon component. So hydrocarbon component is the change of the carbon. The change of the carbon. So sometimes we have a methane, we have ethane, and so on. Yeah, right. So you need to open your chemistry book. Okay. Then from this methane, we can burn. So it's quite similar. If you go to the petrol pump station, if you want to buy the fuel, there can be which one you prefer, yellow or green, unleaded or leaded. Yeah, unleaded or leaded. All right. Okay. Right. And then in terms of the burning process, what is the burning? Burning process is the process of combining with oxygen. It mean if the charcoal contain with CH4, if you burn this one, burning mean you have to burn this CH4 by applying with oxygen. Okay, right. Or in other words, you are burning and you combine, and then afterwards you oxidize, and then from this burning process will give you a water and also release some amount of gases, CO2. This CO2 is polluted gases. And then we need what we need. We need energy. This is the basic. This is the basic of energy around us. Yeah. Either you are realized or not, what you know is turn on the plug, then you get the electricity. But you don't care about where the energy come from. If I ask you now where the energy come from in Malaysia, you cannot explain to me. Maybe you just saying that, oh, hydroelectric. But it's not only hydroelectric, as I said. Yeah. If there is a drought, a kemarau, there is no water, how can you power up the dam system then? Of course, you need some other alternative. Okay. Right, by burning this, you also release the CO2. This is the main issue all over the world. CO2. But there are what? Advantages and disadvantages. Advantages is what? CO2 is very useful for photosynthesis. Am I right? In terms of agriculture. Quite important. The leaf will be converted CO2 to become oxygen. Okay, for photosynthesis. But in some case, the advantages of this is the polluted gases. You go to Kuala Lumpur, you go to big city like Kuala Lumpur, Malacca City. Of course, the traffic, heavy traffic in Putrajaya. Now there are no more MCO. Afterward, you can see polluted we coming again. Yeah, you can see sometimes even if you go to Kuala Lumpur, some of the building wall are turned to be a black color. Why? Because the affecting by the emission from the car exhaust. Because car exhaust release CO2. Even sometimes you are inhale the gases. It's quite dangerous. Yeah. Okay, more hydrocarbon is good. We have start with the ethane. We have a propane. We have a butane. So this all the change. Yeah, more change of the carbon is good. More change, more energy. Okay, that's the keyword. We have up to penta, hexane. In the petrol pump, you can see sometimes you see the word of hexane. Mean that they use 6 carbon atom. Yeah, for the fuel. Yeah, and then 7 heptane. Okay, right. So bigger is better. The bigger hydrocarbon is better. If you count from here, which is better? Heptane is better. Yeah, heptane is better. But in some case, the people will use either hexane or pentane. Yeah. So between this pentane and hexane, which one is good? Hexane is good compared to pentane because the change of hexane is much longer compared to this one. This one have a 6 carbon. This one only have 5 carbon. Okay. Bigger is better. Yeah, this is the definition of this. Now, talking about the world favorite hydrocarbon is octane. This is the best one. When buy octane, Dr. Octopus, octopus, if you watch the Spider-Man, yeah, octopus, because have 8 leg, 8 hand. Okay, 8 carbon. Octane mean 8 carbon. So we have 8 change here. So when you burn this octane, you have more power, more energy. Okay? Right. Now, the trouble with the hydrocarbon, as I said, the effect of CO2. So this CO2, we contribute to what they call as greenhouse effect. Greenhouse effect. So what is the greenhouse effect? That's why nowadays, you are familiar with the term of global warming. Global warming. What makes the Earth, the surface of Earth to be turned to be very hot? Because the answer is, the heat from the ground cannot release to the outer space. That is the answer. Yeah, because as the sun emitted some amount of the sun, so 30, I think about 40% of the sun, power we reach to the surface of the earth, and then we reflected. Now the one that reflected from the surface of the earth is not released to the outer space because it's trapped by the gas. You see this one, Some of the heat from the surface of the ground cannot really because it interact with CO2. It's trapped over there. I mean, the heat is trapped over there. The heat is not go outside there. The analogy is very simple. If you look at on the car engine have the radiator. You imagine if there is no radiator in the car engine, what happened to the engine? The engine will burn. That's why in the highway sometimes you see some car are stuck down because of what? And then you can see the smoke come up from the engine because there is no water. No cooling system. Yeah, the engine is burning. Very dangerous. Now, even we are also in the risk as well. If the surface or if there is a global warming, what does it mean? The surface will be what? The iceberg will be melting. The iceberg at the green or the Antarctica and Arctic will be melting. When the melting, the water level will be high. When affecting, if you imagine, if all the ice in Greenland, Arctic, Antarctica is melting, what happened to our Earth? What happened to our Earth? You will not find no more settlement nearby the ocean. Even maybe the size of peninsula of Malaysia become very small then later on in the future because some part have been raised up by the water because the water level, it's quite dangerous for us. So in this context, we have to imagine this. What effect come from? This effect from CO2 come from the car pollution. Okay. Right. This is all about the green effect. Now you compare between the planet, Mars, Earth, and Venus. We are humankind, human beings are living somewhere around the Earth. So this is the best. This is the best graph that represent, by the green effect for the Earth, for the Mars, for the Venus. So this is the answer why we can live on the Earth You cannot live in the Mars because the Mars is very hot compared to the Earth. Even the oxygen amount on the Mars is totally not similar to the Earth. That's why the Earth is a special place for humankind. But nowadays, you look at on the viral, on the Facebook, the scientists, American scientists, they are keep on chasing to, it's like a racing. They try to get another settlement somewhere around the Mars. The people go to the Mars. Maybe the scientists expect that if anything happened to the Earth, they can emigrate to the Mars. But actually, the Mars is not similar to the Earth. So in this context, this is the answer why Earth is a good place for the human. Okay. Now, if you can see from this is the evolution, the increment of the CO2 from years to years. During the era, there is no technology, no technology yet. Yeah, there is no such pollution. But then afterward, from 1975, 90 something, up to now, this graph is until 2000, actually. But we can expect that until now to 2021, maybe the concentration of population of CO2 may be increased. But to me, the graph should be like this. 2020, 2019, increase will be up to 2019. 2019, the CO2 is increased. Okay? It's increased like this. To me, it's like this. Could be like this. Could be the graph like this. Yeah. Increase up to 20. Okay, 20. Then 2019. Because of MCO. MCO, no people, no more activities. Then the drop. Could be the concentration of CO2 will drop until now. Then after now, can be rentas the era, then become like that. Okay, mean that the human activity produce CO2. Okay, very simple analogy. Look at by a car only, the number of car on the highway. All right, then CO level in the history, all these things this is the evolution of the CO. Okay, the effect of the temperature. Now we need to look a bit on the nuclear power. Okay, so actually, talking about the power, maybe the people can use the nuclear power. It's an excellent energy. Okay, in nuclear power, we have the fuel somewhere on there. We have the water, and then we have the pump system here, and then we have the generator. Generator is somewhere on there. That's why for the nuclear power station, the reactor will be divided into two sections. One section is the generator. Another section is the section for a fuel. And this condiment is made from a special brick. It's very thick of brick. It's even covered by what? By a lead and so on, in order to prevent the contamination of radioactivity material from there. Inside here, we have the uranium rod. We put the uranium rod. The uranium rod is somewhere on there. Yeah. Okay. Then we have the reactor. This is called as the reactor. And this reactor we contain with the moderator and the neutron. In this case, we use neutron to bombard. Neutron we bombard this uranium and produce the uranium decay. From the decay, we return to the chain reaction. And from the chain reaction, we release energy, whereby we have the E equivalent to mc square. That's why we have E equivalent to mc square. mc square. What does this formula mean? This is Albert Einstein formula. Even though this formula is very simple formula, but to me, what does it mean? What does it mean? It means that it's very simple. Yeah. Even though it's very simple, but in terms of the meaning, it means that 1 kilo, if you have 1 kilo of uranium, 1 kilo of uranium You multiply by C square. That's the power that you have. 1 kilo of uranium can give you this power. Mean that you need only not so many sources of uranium to generate more power. That's why the people use nuclear power. Yeah. Okay, now from here we have the steam. The steam will come out there and then over there. And we got the heat. The heat will come here. And this heat, and inside there they got the water. The water and this heat. This is the heat. The heat, we heat up the water inside there. Yeah, inside there. And you have to imagine, the amount of water here is very huge amount. It's not only in the bucket, like not only bucket. It's not like you heat it up water inside the kettle. No, it's not like that. Very huge water, huge amount of water. When you want to heat up the huge amount of water to generate the vapor, of course you need this one. Very big size of this. Then, one after this water is boiling up, we have the vapor or the steam. The steam will go through here. And then the steam go through here and then through the generator. So the steam will be rotate the turbine. The turbine will rotating and then we produce electricity. And from here the steam will go back here and condense to be cold water and then rotate again. Okay, so you have a cold water, yeah? Okay. And this cold water is very hot then, over here, a bit hot. We need to cooling down this water, this steam, to turn a water. We need a what? We need a water from another resources. That's why most of the nuclear reactor, they're built nearby the ocean or nearby the lake. That's why in Fukushima and Nagasaki, if you look at on the incident, okay, why Japanese government, they construct the nuclear power in Fukushima and Nagasaki nearby the ocean, because they need the seawater to cooling down this one. Okay, right. Now the water turn from be condensed to be water, the water go back again, and then the circle will be like that. Okay, but the problem is radionuclide. If there is a leaking over here, you imagine if there is a leaking, all the radioactive waste will be what? Will be turned to be the particle to air. We turn to be aerosol particle. It's very dangerous. It's very dangerous. Even some will be released to the ocean. If the radionuclide released to the ocean, then affecting the fish. Then you eat the fish. The fish eat the radionuclide, you eat the fish. Then radionuclide will remain in our body. Then we are in very high risk. Yeah, very, very, very dangerous. That's why in some case, we see some case like a cancer. Where the cancer come from? The cancer is come from the food, from the drink. Yeah, maybe from the air. That because the air contained with the radionuclide. When radionuclide, like uranium, thorium, remain in our body, it will emitted gamma ray. Mean that in our body, we have the what? Some amount of radionuclide. This radionuclide will be emitted gamma radiation from time to time. It means that you become incredible hot. Gamma radiation affecting. And then from internal part of our body, this gamma radiation will interact with our tissue. Then the tissue will be mutated, turn to be what they call as carcinogenesis. It will be very dangerous. Okay, right. This is some issue with the nuclear power, but it's very clean energy, no pollution. This is very clean energy. Yeah, the pro and con, by the way. Now solar panel. If you look at solar panel, it's suitable for a country like nearby the equator line, like Malaysia. But if even in Malaysia, you talk to me, even though suitable in Malaysia or Indonesia, but you have to notice, you cannot you cannot install this solar panel nearby somewhere around the forest area. No. If you put the solar panel underneath of the tree, how can the solar panel to collect the energy from the sun? So of course you need to cut down the tree. And then you put that's why in America, they put the solar panel somewhere around the desert. Why desert? Because desert there is no tree. For example, Mojave. Solar panel at the desert area. You can see like this. Like that. You can see like that, yeah? Can you see it? Right, solar panel somewhere around there. There is no more tree. No tree. In Mojave, Sahara Desert. This is somewhere around Sahara Desert. But if you install somewhere around there, like in Malacca, I still remember Malacca, if you go to highway, in Malacca, you drive from Malacca, Acro to Johor, there is one solar panel farm. Even though there is some forest there, they need to cut down the tree. So then they install the solar panel around there. Okay? That's why in America, in Australia, okay, they install the solar panel somewhere around the desert area. At the end, they tend to be like this. The solar panel, you need a clear area. No tree. No more tree. Yeah? Okay. Right. In Sabah, for example, so many forests. In Sarawak as well. So, but you can use only, maybe you can put the solar panel on the roof, for example. In the roof, yeah? Okay. Okay, right? Then, where were we? This one. Okay, the problem of solar panel is you only... Quiet. Okay, quiet. Okay, yeah? Sorry, somebody is coming to my house. Sorry, yeah? Okay, I need to speak with to my son. Akmal, please. Okay. Right. So problem is night time. That's why in solar panel, you have the solar panel and they put the battery. Don't ever expect that you put the solar panel without any battery, then you can store energy. No, no, no. If you said that, it's wrong. It's not directly. No. In solar panel system, we use solar to produce electron. The sun will be what? Go through here like this. Let me show you. Let's say the sunlight go through here, hitting on the solar panel. When hitting, we produce the photoelectron, what they call as photoelectron. The electron will be produced here, electron produced here, and this electron will go and store inside this one, inside the battery. Over here, we have the battery. This is the battery. Now, for solar panel, it only in terms of the price of the solar panel is quite expensive. Yeah, it's quite expensive. Then in terms of this battery is long last. It's not long last. Maybe around 7 years. Maybe up to 7 years. 7 years. After 7 years or 6 years, you must change the battery because this battery will be what? Damaged. You need another new battery. This is a problem with the solar panel. Yeah, it's like the car system. Now the people talking about the hybrid system, hybrid car. Actually, to me, hybrid car is not quite expensive as well. It's not save money. It's not saving money. I use the Nissan Serena hybrid for 7 years, but I found that in terms of spending of the money, is nearly equivalent to you using a normal car, non-hybrid car. Because you know what? The people will charge you on the battery. The battery is very expensive. Yeah, this battery is quite expensive. Now, who say that this system can save the cost? No. If not, yeah, to me it's not. But it's only alternative. If there is no power, you can use solar panel. Yeah. right? But you can only use at night time. Mean that you store the energy in the battery. Okay, then on night time you can use the power from the battery. But how long the power from the battery can be long last then? Maybe you turn off all the all the electric source from TNB, and you depend on this from 7 o'clock at night until what time? Tell me. With this amount of battery, this size of battery, how long it can last? Maybe from 7 to midnight, 5 hours. Now, one after you want to continue from midnight to the morning, maybe you have to wait until tomorrow morning to charge again. Then the data, then on the next day, the battery need to be charging. How is charging? Using solar panel. Right? The answer is storage. The problem is this one. But to me, the answer is maybe in terms of the storage only, yeah, because you can store the energy using solar panel. Wind power. In Malaysia, very hard for you to find the wind power. But some people make a wind power, but wind power only for what? For only for replica, something like that. Yeah. But if you go to Holland, you go to Dutch or Netherlands, Holland, or maybe UK, most of the European country, maybe in Holland, in Sweden, in Norway, they use wind power system. Why wind power? Because why? Because the velocity of the wind around there is very high. Very high. Yeah. In terms of the velocity of the wind is very high. I still remember when I walked from my flat to the shop long time ago. Yeah, the wind in England is very, very high then. My cap had been released from my head then. Fly away. It fly away. Because the wind is too strong. Yeah. So in Malaysia, if you want to use this, we need to ensure you need to measure the power of the wind. Yeah. Okay. But we need what? We need the wind power station like that. You need inside on the top of this, we can see the blade. Huge blade. Yeah. We have 3 blade or 4 blade, whatever blade. Then inside there, behind here, we have the rotor system. We have one after the fan of the fan is rotating by the wind. The fan will rotating. The fan will rotate. Whatever in the clockwise or anti-clockwise, it depends. Sometimes we can go anti-clockwise. It depends on the direction of the wind. Behind there, we have the motor, the gearbox, very huge gearbox. Gearbox here, yeah. So from this gearbox, then we have the dynamo behind here. Dynamo. So this gearbox we rotating, and then this dynamo we produce the electricity by using induction. In physics, you know induction. What is induction? Induction is what? You put the coil, you put the one rod like that. Then afterward, you put this rod into the coil, a solenoid like that. A solenoid like that, right? Okay. Then from there. So this concept in induction, we use in the dynamo. Induction. So from there, induction, we give us the electricity. Yeah. The electricity comes from the dynamo then. Yeah. Okay. This concept is like a bicycle. In bicycle, we have a dynamo, right? We want to cycling during night time. Oh, nice one. Okay, you want to cycle night time, you depend on the dynamo, bicycle dynamo, right, to produce the electricity to light up your lamp. Otherwise, you cannot cycle at night time then. Okay, but nowadays the people use battery, yeah. Then we use the wave. We have the geothermal system. Yeah, like that. Hold on. I lost the... Where were we just now? Okay, this one. Sorry about that. Okay. Now we have this. Where were we? Okay. talking about this wave. The wave, the geothermal, yeah. So this is the geothermal. If you go to New Zealand, it's actually depend on the area that have a volcanic area. Mean the heat come from the core of the earth. Yeah. So nearby the volcanic area. That's why you go to New Zealand, for example. They use the geothermal system. The word geothermal mean the heat which come from the core of the earth. Because if you look on our earth surface, some area have a volcanic area. Yeah, right. So even if you go to like spring, water spring, hot water spring. In Malaysia also we have the hot water spring in Muar, Johor, Johor, yeah. Muar in Malacca, in Negeri Sembilan, we have the hot water spring. That's why if you go to hot water spring, you can smell a sulfur. The major issue of this is a sulfur, because if you pile up this construction with the metal will corrode. That's the problem. Even the corroded will also affecting on the generator system and so on. Yeah, the problem with this. Right, now problem, and then this is all we call as renewable energy. So this renewable energy I will explain in detail later on in chapter 2. Yeah, by the way. Right, so in some case, the people will use now the word of hybrid system. The hybrid technology. Yeah, and even sometimes the people will use the fuel, battery, and then we have the one other we call as hydrogen energy. The people talking about the hydrogen technology. But actually, yeah, hydrogen is good because produced from the water, H2O. But in some case, we need to take care on the risk. There is incident of Zeppelin long time ago. The Zeppelin incident. Zeppelin is a huge air balloon. Yeah, that's the engines or the balloon have been expanded using the hydrogen gas, because hydrogen gas is very light. The balloon, yeah. So the catastrophic disaster is like this. Yeah, hydrogen is very easy to be burned up. That's why they got incident like this. So talking about this hydrogen technology, we need to consider in the future whether is worth this or what on is worthless then. Okay, right. So this is all the point on this. All right. So I have another point. Then we have to go back under some concept of the transformation, energy transformation. Right. Talking about this, we need to look at on this slide. Okay. Right. This is the issue in US. Yeah, in Malaysia, I have one document in Malaysia cases. So I will give you, and then you can read it later on. For the issue of energy in Malaysia, we have this one. Okay, I can pass it to you later on. You can read all this thing. The issue of energy in Malaysia. In Malaysia, how we generate the use of energy in Malaysia. Yeah, it's a very good article. I will ask you to read this one. You read this until page 12, secondary, until here. Okay, right. You can read all of the thing. Okay, maybe you can read until page figure 16 is enough to me. Like the rest, you can read as extra information if you want to know further detail about the energy in Malaysia, all over here. Yeah, right. Okay, thanks. I will give you later on the one. Okay, now as I said just now, this is the graph yeah, on the use of energy in US, but I reckon that in Malaysia it's quite be the same thing too. So we can see, yeah, the use of energy in terms of the barrel per year of the barrel of the oil, you see increase, yeah, increase. Then after decline, the decline depend on the storage, yeah, storage by the way. Then could be up to here, up to here, and then one after there is no fuel, then you decline, and then the people need start to think on the another kind of alternative. Right, now talking about the energy. So what is energy? Energy is the capacity to do works. The capacity to do works. That's the definition of the energy. What is work? Okay, this work, it can be defined as we know from in physics. We write the work as W equivalent to force times displacement dot S, whereby this is the work, this is the force, this is the distance. Yeah, force time distance or displacement. Okay, for example, if you walk from your accommodation to campus, okay, mean that there is the changing of the what location. Then you walk, that you are doing a work. When you running, you jogging, you doing a work too. Yeah, you cycling, you do the work too, because from your body you use. That's why in our daily life you need to eat. If you eat more, then produce more energy. Then more energy you can run then. Okay, you can run. If you didn't eat, then there is no energy inside your body. How can you run? Okay, you cannot run then. Energy is heat is the energy. Now, of course, we need to produce heat in our body. In, like say, as I said, in Malaysia, you cannot feel this kind of situation because we are tropical. In the near, we are in tropical weather. Yeah, you can feel the heat from the morning up to the evening. But if you live somewhere around Eskimo, the Eskimo people need to eat more food. They eat the fish. When they eat the meal, that means their body turn become very hot. It's like as well you eat the biryani kambing. Kambing 40 hari, yeah. Very famous in Johor. Some people say that they cannot eat the biryani kambing because their body will be very hot then. Okay. Who turn on the video, the mic, please turn off, please. For those who turn on your mic, please turn off now. Not Ashira, please turn off your microphone now. This is a lecture. Where are you now? Turn off your mic. Okay, I don't care because I'm speaking. I give lecture now. I don't know. I don't care where were you, but please make sure your microphone is off. I'm giving lecture now. Right. Talking about the heat. Yeah, the heat. The energy. No, as I said, that's why the people need the heat. If you didn't eat the food, then your body become very cold. You cannot move. That's why in the movie, you watch the movie, what called one movie, Stay Alive, what called, I remember. One football team, yeah, in the plane, and then the plane there is one incident in Peru, the Bolivian football team, and then the flight have been say incident of the flight, yeah, and all the survivors are leaving. Some people are survived during the incident, yeah, and no food. There is no food in the somewhere around Peru, I think Peru or Chile, yeah. Okay. Then they have to eat. They find they have to eat then. They have to eat, and then until there is all the food are gone, they have to eat. Eat. They have to eat then. Even their friend body then. Yeah. In order to survive. If you watch that movie, yeah, it's true story, yeah. Okay, they eat and to produce the energy. If you didn't eat, then your body become very weak. You cold then. Even I don't want to give you an analogy for the during fasting month is different. Because we are Muslim, fasting is good for us. Yeah. But like analogy, one after you break, you have iftar, then your body become very fresh. You have water, you can drink, and then you can. Okay, all right. This is one analogy, simple analogy. But fasting is good to me. Yeah. Okay. Right. Right. This is the term of heat. Heat is flow from hot to cold. Okay. Right. Now, talking about the energy, work, and heat. Both of work, heat are in form of molecular motion. Yeah. Energy can be destroyed or not. It's not be destroyed, but it can be transformed to one other. Okay, talking about the work is organized motion, the heat random motion. Okay, random motion, because sometimes the heat can be random motion either if you look at on the thermodynamic law, number one, yeah, the heat will move from the hottest area to the coldest area. Okay, energy is the sum of all the molecule motion. Now talking about this heat, the unit is in joule. This is the definition of joule. Yeah. The amount of energy required to increase 1 kilo blah blah blah. Okay, this is one example only. Yeah. Calorie, this is the definition. Calorie equal 1 calorie equal 4.184 joule. That's why if you look at on the level of the any kind of foods, you can see there is a level of the 1 kilocalorie of the meal that you eat. If 1 kilocalorie mean 1,000 calories. The calorie mean the energy that can provide into your body. Then, okay, right. So we talk about the energy transformation. Now we know what is energy is. The energy is this definition, capacity to do works. Okay, right. In terms of energy transformation, why energy transformation is very important? Because as I said in the previous example just now, if you look at on all the example, energy is transformed. All example that I give you just now, energy is transformed. Yeah, this is from what? Mechanic to electricity. Yes, I like that. Yeah. Okay. Right. Maybe this one is from heat to electricity. Right. Therefore, in the context of energy transformation, you need to look at on the both of the thermodynamic law. We have two thermodynamic law. Number one is first law of thermodynamic, whereby for the first law of thermodynamic, it says that energy is neither created or destroyed. Yeah. But energy can be conserved. This one. And the mass also conserved. Means that energy cannot be destroyed. Yeah, it cannot be destroyed. But energy can be converted from one point to one form to another form. What does it mean? Okay, I will show you later on. So, and also in terms of energy transformation, energy is normally generated from the fossil fuel, or maybe a combustion, yeah, or the burning. And from the burning, the energy can transform from, maybe you burn using a methane. I mean that you are burning the chemical farm, produce, so maybe a chemical reaction and release the energy. Then we have the chemical energy to the heat energy. Okay, all right. And then the engine transformation and so on. Now, this is the transformation. The transformation. Anybody left my lecture? I don't care. Yeah, for those who left my lecture, I don't mind. But when after I give you the test, you cannot answer my question. Don't ever blame me. For those who are there to left my lecture, I don't mind. You can left. Yeah, I challenge you. For those who are there enough to left my lecture, go ahead. But if you cannot answer my question later on in the test 1 or test 2, don't ever blame me. Even though I cannot see who left my lecture. All right. Now, you see, this is what the concept of energy transformation. What I said, this is the burning. You have the water. You burn. You apply the charcoal. You put the charcoal. And the charcoal, we heat out the water. The water, we transform to the steam. The steam, we go to the turbine. And turbine, we rotating. And turbine is connected to the generator. The main function of it is the steam. The steam will allow the turbine to be rotating. One after the turbine is rotating. No, of course, you got the generator here. Yeah, as I said, there is induction. The wire around the generator here. Then from the rotating of this blade or this metal, somewhere around here. So of course there is like a big dynamo here, yeah. So the current we produce from the induction, then you get the current, right? But the steam go again and then again and again like that. Now, in terms of the transformation, what we can see, mean that from the heat, this is the heat. The heat go, the steam rotate this turbine. Mean that the heat transform to mechanical. Because turbine is mechanical energy. Mechanical energy converted into electricity energy. That's called as energy transformation. I repeat again. From the heat, the heat energy transform to the mechanical energy. This is mechanical energy. Mechanical energy transform to the electrical energy. Or finally, we can consider like this one. Potential energy to the heat. The heat, because potential we burn. Yeah, as I said. Potential energy, in this case, we're talking about the chemical bonding. We break up the chemical bonding. From the chemical bonding, you break it out, and then we got the heat energy. From the heat energy, and then got the heat energy, we have the steam. The steam will be what? Rotating the blade. The turbine will be rotating, so we have the mechanical energy. From mechanical energy, yeah, we'll be rotating, and we have the induction, because the generator, there, behind there is the loop of wire, together with rotating blade of the generator, we induce the electricity via induction. You have to read a bit on induction. What does induction mean? Over here, what mean we have this? Because of, we call as induction. Induction. We have to read what is induction is all about. Yeah. From the induction, we have this electricity. Or you have this. So mean that the transformation from here to here to here to here to here. Now my question, does the amount of energy from here and here, is it equal or not? It's not perfect. If this one is 100 joule, over here could be no longer 100 joule. You cannot get exactly 100 joule because there will be energy loss. Energy loss, where? It's come from mechanical loss. Because in mechanical system, we have a friction. Over here, we have the loss. The loss in terms of friction. Friction. A friction between metal and metal and so on. Because of the friction, maybe not 100, but could be 70 joule. From 70 joule, you induce and then the current will be produced. It's not exactly perfect. So 100 joule. Yeah. Okay. In terms of, in this context, what I said from 100 to 70, from 100 joule, from this example, 100 joule to be, is not, if we know 100, as I said, you cannot get 100 joule. No, it's impossible. You cannot get this, but you can maybe lower than that. Why? Because of this, I said is a factor of energy loss that contribute by this contact, because this one could be. So therefore, we have one term, what they call as energy efficiency. In order to explain on this, we need to know about what does it mean with the energy efficiency. What is the energy efficiency? It is a measurement of the ability of the engine to transform chemical to mechanical. So in this context, yeah, we can write it as efficiency. Normally, this efficiency we write as a symbol of epsilon. Okay, epsilon. So the efficiency is equivalent to efficiency of a power, a time efficiency of the boiler, this boiler, okay, efficiency time the turbine, this turbine. So we need to consider on the efficiency of the boiler, efficiency of the turbine, efficiency of the generator. Three things. All these things. Yeah, boiler, turbine, and generator as well. And power transformation. What does it mean? From here, the electrical current that you get from here, maybe you get about, could be, let's say, 100 volt produced. Yeah, during during the distribution from the station, from this one to your home, maybe energy loss, electrical loss via the cable, because the cable have resistivity. Yeah, maybe energy loss from here to here because the cable have resistance. So the one that we have could be no longer 100 volt, could be below than that. But in our situation, normal situation, that's why when you plug in, you turn on your plug, normally, what is the power? The voltage that you gain at home. Alternate current that you have. 24 volt. Which one? It depends. Yeah, it depends. That's why if you look at on the plug of every single system, yeah, and even the house, you use the transformer. You have to use the transformer. Because in the body of the plug, there is a transformer. It depends on the type of device you want to use then. if you need to charge, it depends. Yeah, it depends on the device that you want to charge. Right. Any questions so far? Any question? No. Okay. I go ahead. This is some of the example of the calculation. Okay. This is the example of the calculation. Right. So you can have a look on this. Right. Let's consider, like in the example, if you want to calculate the efficiency of all these things. So by using the formula, okay, 0.6. Anybody want to ask me the question now? Anybody? I give you 1 minute to relax. We continue. Okay, 1 minute. Because I can see somebody turn on their mic. Afterward, I am waiting for any question from you. Okay, we still have another 50 minutes time. Class, we still have another 15 minutes time. Sorry, I turned on my camera, by the way. I forget to turn on. Okay. All right, then. Okay, then we have this calculation. Then from this calculation, you can see, yeah, right? So each of these contribute, yeah. The boiler contribute about a factor of 0.6, 0.9, and then this one, the power transmission, 0. And so on. So all this you convert it, you divide it into this one. What does it mean? 16 divided by 100 because this is in percentage. So mean that this one, 90 divided by 100. Then you got 0.9, 0.7. This one, 75 divided by 100. So all these things, you calculate answer. Altogether, you got about 34. 0.34. So this means that this is equivalent to 34%. So mean that from the idea of this is not 100%. From 100%, you get only, at the end, 34% only. Converted into the electricity. This is 34% that convert to become electricity. Okay? This is the converted into the electricity. All right? Okay, this is another example of the calculation, etc. And talking about this, we have the potential energy, we have the kinetic energy. Potential is come from bonding of the chemical. Kinetic energy is from the mechanical. When you deal with the mechanical part, of course, we have the mechanical. I mean, all the things are rotating. Yeah. Kinetic, yeah. What is kinetic energy? What is kinetic energy? EK equivalent to, you know this formula, yeah? 1/2 mv square. Okay, this is kinetic energy. So, mv square. So we have thermal energy, random motion of the molecule. Entropy, another word we have entropy. Entropy, the randomized, yeah, in the position of energy level. Yeah, right. This is respect to the what we call as thermodynamic law. Then if we look at on the second thermodynamic law, we'll be focused on the entropy. Okay, focus about the entropy. So you can have a look later on this. What is the definition of entropy is all about? Right. But if you look at on the some other example of the calculation, then for example, in terms of the chemical reaction that occurred just now, so we consider like this kind of reaction, methane. Every single part of it, we release their own energy. So in this context, That's why we have the exothermic process, endothermic process. Exo, endo. Exo is release. Endo is not release. Yeah, that's why we have the car exhaust. Exhaust mean that release. Yeah, exothermic, endothermic. So that's why most of the combustion system have a exothermic. Exothermic mean that what? Combustion, yeah, combustion. Car combustion engine, for example. You are release the energy. Sorry, you are release the CO2, for example. The system release the CO2. It's called as in the exhaust system. That's why we call exhaust. Exhaust mean that all the heat will be released from the exothermic. Okay, now how much amount of 1 mole of this methane can be produced? But you need to calculate. Okay, 1 mole of CH4 equivalent to this one formula. Okay, molecule formula, 16 grams divided by 1 mole time, okay, the energy of this. Okay, the energy of this. Okay, 1 gram of burning, we get about 50 kilojoule. So mean that 50 kilojoule divided by this one, then you can calculate. Finally, you get about you can get 1 mole of CH4 will give you around 802.3 kilojoule. Okay, this is how we calculate. Right, so in this context of the reaction, we have the, as I said, energy production and energy reaction. Energy reaction is there like the, on the way how you get the energy. We call the from here, what we call here is the chemical reaction. The chemical reaction, or in other words, we call as an energy reaction. In this context, we consider this is a chemical reaction. Yeah, the chemical reaction that will give us the energy. This kind of energy reaction, so in terms of the chemical, is this one. We burn the methane by introduce the oxygen into, by combine the methane with the oxygen, and we will burn. When you burn it up, then you get energy. Now, the difference between this one and this one is approximately, one after you calculate just now, 800 something, it means that the one that you have is about this. Negative. Yeah, right. So this we produce this one. Yeah, you are release the energy of 802.3, and then finally from here, will give this one. In order to get here the reaction, this reaction will give you a product of this. The product of energy that you have, this one, this energy that you use. And then, but unfortunately, this reaction release this one, CO2, and also release with the water. But the one that you need are this energy. Okay, that energy will move the engine. Okay, right. Okay, if you look at on the car combustion system, for example, okay, we can have a look on the car, analogy of the car combustion system. If you look at on the car combustion system, example, yeah. You look at in the video how the car combustion system work. Now you see this one, yeah. Now I want to see the video. You got any video? No video. I'm pretty much interested on the video only. This one. Wait. Okay, 4-minute video. Have a look.
A car engine generates power from the expansion of compressed air in a contained...
Now that's what I'm trying to say, yeah. The CH4 methane, the what? Okay, now octane or whatever methane you use, octane go Because that's why in the car, they got the what? What they got in the car? One part to, to turn the gas, to turn the fuel to be the gas. So in the car system, the fuel will be turned to the gas. Yeah. The gas will be go to the block engine. Not the fuel go here, no. The gas. Yeah. Okay. Have a look.
Cylinder with the help of fuel. That is why it's called as an internal combustion engine. Before getting into the working, let's see the main parts involved in the working of an engine. First, the crankshaft. This is the part which converts the linear motion of the piston to a rotational force. Next, the pistons and the piston rods. The pistons will be pushed down by the expansion of compressed.
Over here, we have the gasket. This is the block of the piston, this gasket. Why the punch of the gasket? The gasket in order to prevent the gas to be released. Okay, because this is tight. This gasket is tight. It's very close to the block of the engine. That's why you got gasket, yeah? Okay, right. Very.
A carton of compressed air in a contained cylinder. Why it's called as an internal combustion engine. Before getting into the working, let's see the main parts involved in the working of an engine. First, the crankshaft. This is the part which converts the linear motion of the piston to a rotational force. Next, the pistons and the piston rods. The pistons will be pushed down by the expansion of compressed air and turns the crankshaft. And the valves, which controls the flow of air and fuel into the cylinders.
Okay, the valve just now, you see.
Crankshaft. The pistons will.
I want to stop why.
And the valves, which controls the flow.
Okay, this valve, one inlet, one outlet. Inlet mean that the gas, the fuel that tend to be a gas, go into the inlet, the gas goes straight with that, and then one after the reaction occurred, you release the heat. So this is outlet, one inlet. That's why we had the valve, yeah?
Flow of air and fuel into the cylinders. These valves are driven by the intake camshaft and the exhaust camshaft, and the camshafts are driven by the crank itself using a timing belt. There will be idler pulleys and a tensioner pulley to hold the belt tight in place. This here is the internal structure of a four-stroke inline four. You
see the burning there? Yeah? That's what I say, like octane, go inside there, and then we burning, and then the burning there, we move from the fire. When they fire up, then we push the piston down and up and down and down and up. Okay.
Cylinder, DOHC engine, which is commonly found in most hatchback and sedan cars. A four-stroke engine should pass through 4 different strokes to complete one cycle to produce power. They are intake, compression, power, and exhaust stroke. The crank to camshaft ratio is 2:1, which means it will take 2 crank revolutions to complete one camshaft revolution, and the camshafts are designed in a responsive manner to open or close based on the corresponding strokes of each cylinder. Let's take a look at a single cylinder and see how a 4-stroke engine works in detail. In order to ignite the air-fuel mixture, a spark plug is used. This will ignite the compressed air-fuel mixture with the help of an electrical spark. We will take it down by each stroke. The intake stroke. The inlet valve opens and the downward movement of the piston creates.
So the spark plug will produce the fire. Yeah, the fire. Alright? So without spark plug, there is no fire up. Okay?
So suction. This pulls the air-fuel mixture into the cylinder. Once the air-fuel mixture is in the cylinder, compression stroke begins compressing the mixture. At this time, both inlet and outlet valves stays closed. At the end of compression stroke, the air-fuel mixture is ignited by the spark plug. The explosion exerts pressure and pushes the piston down. This is the power stroke which produces power to the crank. At the exhaust stroke, The outlet valve opens and the piston pushes out the burned gas. The cycle starts again from intake stroke, keeping the engine running and produces power.
Now, where's the energy now? The energy that I'm talking about is what? The energy that I'm talking about now is this fuel. Because this fuel is come from what? A fossil. As I said, the fuel is come from the fossil. Fossil contain carbon. Yeah. So from the carbon, we have the either that one I said, hexane, octane, all these things. All these compound will go into the block and then be burning. That is the main issue of our topic, today topic. Yeah. Okay.
For a carburetor engine, the air and fuel are mixed inside the carburetor assembly and fed to the cylinders. In the case of a fuel-injected engine, the fuel is injected into the intake manifold.
Okay, now at least you got some idea. What is that one? Okay, then we go ahead. Now, in the video just now, all these things are respect to this. Okay, all right. Then we have last one of this. We have direction, we have production, and then we go. Okay, right. So we have this on the fuel. We have this. What is endothermic? Endothermic reaction, exothermic reaction. Yeah, in endothermic reaction, energy of the production must be bigger than energy of reaction. Yeah, and then the energy change is positive, and this contact energy is absorbed. But exo production is less than reaction, and the energy will be turned to negative. That's why we have the negative value now. This negative indicate that exothermic. Exothermic is positive, means it's endothermic. Yeah, if positive, endo. Negative is exo. Right. And then energy is release. Release. Okay, then you can read all this. And then talking about the bonding. The bonding of, the fuel just now. Yeah, as I said, the potential that we consider here are the potential of breaking up the bonding. When we talk about the bonding, you see, every single molecule have their own bonding, like hydrogen. Hydrogen very easy. Yeah. Then one bonding, then we have the carbon, C, and then we have nitrogen and also on. Yeah. When this one bonding with this carbon and carbon. Yeah, and then we have and etc. Yeah, okay. Now, if multiply carbon, for example, C double bond C, the bonding is this one, this value. We need to break up this bonding. We have to have this value. Then this one, when we have the more bonding, quite very difficult then for you to break up. So, two bonding is simple to break up. Yeah, right. Right, and then we have the double bonding and etc. Right, now all these are very important in order to break out, in order to produce the energy. Then this is one other example. Yeah, hydrogen and hydrogen, oxygen double bond O, and this one. This is the way how we calculate the bonding energy. And if the energy is released, you can see over here, this is a reaction and the product. Yeah, reaction and product. Okay. By that, I think our topic is up to here. We finish with the energy transformation. We finish with the energy use, and could be next week we start a bit on this. We revise a bit on this topic. Yeah, and then afterward, okay, talking about your assignment. I want to give you assignment now, by the way. The assignment will be, I will type it later on via the, okay. Now, let's see, where are we now? Okay, right. Right, we are somewhere around here. Now, we are finished at the chapter 1, somewhere around the transformation of energy. I don't like this one. Hold on. Okay, we are somewhere around here. Okay, I explained to you about the chapter 1 on the 1.1, 1.2, and 1.2, and etc. Next week, inshallah, I give you a bit, and then we straight away jump to the renewable energy. Because you have to remember, this is 2-hour lecture. 2-hour lecture mean that I must have, get delivered the lecture within 2 hours. Make sure all the chapter is completed. So by next week, if there could be someone note, maybe I show you a bit on the some more note that is related to this one. Okay, finish on that one. That maybe there's not the Malaysia contact, and then this is the energy farm, and then we have another one on the. Okay, I will explain a bit later on. So next week we start a bit on this, and then we continue on chapter 2. Chapter 2, which is under the topic of renewable energy. Now, for your assignment. Okay, I want all of you to write article, and the assignment I will put in the auto system. Auto system, yeah. Okay, for those who can access outer system, I will give you via here individual assignment. I will create one new activity, and then 55, all these 55 students, you can straight away. Now I can see in the class about 70 of you. I'm not sure how many students from Indonesia, because I reckon that the list that I have now is around 55 from 55 plus 15. How many? 70 of you, yeah? Okay. Around 70. Yeah, exactly 70. I can see about 70 just now. Right? 70 from Indonesia, 15 from Indonesia, plus 55 from Malaysia. We have 70 all of you. Now, back to the assignment. Assignment. For those who can get access on this, I will write down over here. This is individual assignment. Individual assignment. Now, this assignment, okay, I give you until the middle of the semester. You have to look at on the calendar. When is your mid-semester break? Please have a look for me, please. Somebody can please have a look. Your semester calendar, please. When will be your mid-semester break?
This sem, we are not having any sem break.
Why?
Mid-sem break.
No. No sem break. Are you sure?
Yes,
No.
Prof.
Yeah. If not, I don't mind. But I need to look at whether you get any calendar or not. Let me have a look. Because we must have over here. Yeah. Academic calendar. Calendar, academic. Okay. This one, right? Am I right? Am I right? Oh, this is diploma. No, this one, degree. Okay. For those, we are somewhere around. Is it the right one? Is it the right
No,
one?
doctor. No.
No, doctor.
Session 2021-2022.
Okay. We are, today is, what date? 13, yeah? 13 October. So when we be? So we start around, today is 13 October. Semester, is it semester? Why the calendar to be
Prof,
like
you
this?
opened the last session. The past session.
Oh, the past one, yeah? We got any, where's the new one? New one, where's the new one? Show me. Wait. Is it the new one, right? Is it the one? Is it the one? Ah, okay, this one, sorry. Okay, sorry about that. Okay, wait. Okay. Where were we? Today is this is my better. October. We are here. Start. We are in this week. Am I right? Am I right? Oh, not right. Yes.
Yes,
No,
Prof.
yeah. You are right. No. Okay, I want all of you to submit this by week 7. Week 7. Week 7. So we are here. Week 1. Okay. 1, 2, 3. 3. 4, 5, 6, 7. End of November. All of you. Okay, I said end of November, right? Am I right? November, yeah? November, yeah? Mean that 1 month and a half. Assignment 1. Assignment 1. By end of November, I want all of you to write. Okay, you get ready. One article. I write it down. Hold on, yeah, I will upload later on, yeah. One report. You need to submit one report. Around 10 to 15 pages. Submit, please submit. Okay, I type down. Hold on. Please submit. I give you the task now. So you write down. One report. Within. Okay. 10 to 15 pages. Complete. Yeah. Pages. Including front cover. List of content. Okay. And your each subsection. Yeah. And each subsection you want to write. Including. Okay. Start with introduction. Okay. Introduction. Then you do like literature review. Some literature review on the issue. Okay. On the issue that I will give you. And then you write discussion. Review means you get from the article. Discussion is your comment. Okay? Discussion. Mean that dear discussion. Discussion. And comment. And then conclusion. Simple. Simple. Yeah? Conclusion. And then reference. List of reference. Reference. And this literature, you must put all point and put point of. Okay, can you see? This is your assignment. Okay, your assignment is this one. Okay, this is your assignment. Right, I will upload this one later on. But meanwhile, I will. Okay, the body of this report must contain with number 1, number front cover. You must have your front cover. Okay, front cover, list of content, and etc. Okay, but you must have. Okay, number 1, front cover. After that, I need you to have list of content. Okay. The page is around this one. Make sure 10 to 15 page. You can include the picture, whatever. The point, the picture is in the literature. So you must have this one, the list of content. Okay. Your body, it will be start with the introduction, literature review, and then I want you to comment. This is you have to use your own sentence. Okay. Use your own sentence. At least 2, 3 page is enough. Comment. What aspect? You'll do literature review, blah, 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 blah. And then you discuss. Okay, all right. Now, what is the title? The title is energy. Okay, evolution in Malaysia. For those who are from Malaysia. Okay. From what years? Okay, initial revision mean from what years? Okay, you go back. You have to revise the history of the evolution. From the past until now. The past mean it's up to you. Okay, this is for those who are from Malaysia. Okay. For those who are from Indonesia student, I change the topic. I want to change the country. Yeah. All right. This is your assignment. Title number 1 for those all the Malaysia student. Title number 2 is for all mobility student. So for inbound. Okay. Question on this? Any question to ask me? If you want to ask me now. If you're blur. If you're okay, then I don't want to repeat again. For any question? No. No question, yeah? Oh, undo. Okay, if no question, then I can. Okay, I try to. Are we safe? Now I copy here. That at least you get some idea what to do. Yeah, I copy here, and then I will. Okay, this is your. You see this one, right? I can save, or maybe I can. I paste down. Can I paste? Oh. Okay, I paste already. Okay, you have a look on your WhatsApp. Okay. Look at on your WhatsApp. Your assignment is given already, class. Do I talk to the wall or what?
Okay, doctor.
When I ask somebody, respond. It looks like I'm talking to the wall. When I ask you, you answer. Okay, our class is over. Assignment 1. Any questions so far? I stop my record now.
No, sir.